at some of these concepts in a bit more detail now, and particularly into how these concepts could be used in terms of environmental management, perhaps, and in terms of understanding change and damage when it comes into individual objects. We've talked about the value framework. We've talked about how long collections might need to be kept for in the eyes of users. We've talked about what particular aspects of an object might render an object unfit for purpose. Kat talked a bit about whether an object can be displayed or whether an object can be handled. So those might be two purposes of use we could be interested in. And we're going to explore fitness for purpose in a bit more detail. We're going to look at some of the agents of change in a bit more detail and how those could be combined into a single dose response function. We're also going to look at how wear and tear accumulates in objects as users leaf through a book or through an archival folder. And later on, Kostas is going to mention very, very briefly material survey principles. So, and the reason why we're looking at library and archival collections really is the fact that we've got a lot of past research into these materials. Materials research into aging of paper has been going on for decades, and in this project we happily summarized some of the research data from the 1990s on. And the other reason why we looked at these collections is because we're looking at millions of objects of reasonably similar significance. So we can apply the statistical principles of modeling fairly confidently. We're also looking at distributed properties. The one novelty in this approach is that we're looking at each individual object being slightly different, because all objects age at different rates and they have different material properties, and that affects how a population in general will decay in the future. We're also looking at collections as a unit of management, so that equal access or equal environmental policies are, or strategies are applied to a single collection. However, in order for our model to work, we need the following essential inputs. What the planned lifetime is. Kath talked quite a bit about that. And we agreed to take the planning horizon of 500 years, which looked reasonable, because it satisfied about 90% of all users. Other planned lifetimes could be taken into account as well and could be used in the model by other users very easily. We've also looked at fitness of objects, and we looked at that with a number of individuals, with a number of users. More than 330 users participated in a survey of fitness of objects, and we in collaboration with our partners, we synthesized this knowledge into a single dose response function. We discussed this plot into much detail already, and just to say that this is the planning horizon we will be using, 500 years, because it satisfies approximately 90% of all users. And we've also discussed that this plot is almost independent of the type of collection we're discussing or of the type of materials we're considering, because we get the same plot for geological collections and for organic materials. Planning horizons might have less to do with material properties than our general tendency towards the future. The other aspect of objects and collections we were particularly interested in is fitness for purpose. In her presentation, Kath mentioned the two aspects of an object in terms of purpose, to be displayed and to be handled. And these are the two purposes we were particularly interested in the context of historic libraries and archives. The terminology is used in collection management, however, we wanted to pin down some of the principles and some of the details in this particular exercise. In order to understand and in order to tease out the detail of fitness, we presented 331 users of libraries and archives with differently degraded documents. These were all historic documents. They all looked very similar. However, some were degraded slightly more in terms of color. Some were degraded slightly more or less in terms of mechanical degradation. Some had larger or smaller pieces of text missing. Some had larger or smaller tears. So we were interested to see whether tears and pieces of document missing and whether discoloration matters to users in the context of display and in the context of reading with handling. So we were looking at two purposes, the purpose of reading with handling and the purpose of display. And we were looking at three elements of physical degradation: missing pieces, discoloration, and tearing. Because these are the symptoms which came up in the questionnaire which Pat described in the previous presentation. The experimental design behind this experiment was quite complex, and we'll talk a bit more about that in the workshop later on. We asked all the 331 users to grade the 17 documents, to rank the 17 documents according to these categories, and we didn't provide any description for any of these categories. The fifth category was unfit for purpose. In the context of this project, we do not consider an object to be completely useless when it becomes unfit for purpose. We only assume that it needs to be managed differently once it becomes unfit for purpose. For example, unfit for being delivered to a user in a reading room. If a document is too fragile or too torn or too many missing pieces, then it simply needs to be displayed or delivered in a different manner, which might mean more resources. We also explored three value scenarios. One value scenario was no scenario. So we weren't asking participants in this workshop to assume any particular value of that particular object. So the value set which users used was, in our eyes, quite random. So each user was viewing the object from their own personal perspective. In the other two scenarios, we asked the users to imagine that that particular document has personal significance to them, that it describes a particular event in their family history. And in another value scenario, we asked the users to imagine that that particular document has historical significance, so that it describes a historical event in the history of their country. This worked to an extent, but not quite as well as we wanted to. But we were able to collect some interesting data. So at the end, we had three value scenarios, two purposes, so 6 different types of workshops, which were then carried out at the National Archives in Kew, at the Library of Congress, and at the Wellcome Library. So thank you to all of those who participated to these workshops. And we ended up with quite a large number of participants. To cut a long story short, we ended up with fairly similar fitness for purpose curves. This is our fitness for purpose. Remember that category 5 is unfit for purpose. So all of the objects categorized 5 or between 4 and 5 would be deemed unfit for purpose. And it turns out, perhaps expectedly, that objects with large pieces of missing text are generally deemed or categorized as unfit for purpose. This was interesting because this means that users in a library or in an archival context are not particularly concerned with color at all. Remember that we have differently discolored objects. Users in a library or archival context are not concerned with color. Color doesn't contribute to whether an object is fit or unfit for purpose. Interestingly, even tears do not matter much. It's only when an object clearly shows signs of missing text that users become concerned and that users start categorizing the object as unfit for purpose. Interestingly, and perhaps rather disappointingly, the personal value scenario didn't work. It overlapped with the random scenario. However, if the document was perceived to have high historic significance, then it never became unfit for purpose. So regardless of how much text there was missing, the object never became unfit for purpose. So this explains how our attitudes to documents affect how we rank them in terms of fitness for purpose, either display or reading. Also interestingly, it doesn't really matter whether the purpose is reading with handling or display. As long as text is missing, then objects will be considered unfit for purpose. Now, these results need to be interpreted in terms of how quickly wear and tear accumulates during handling of objects. And this was the next piece of research we were interested in. And of course, as material scientists, we know that wear and tear will accumulate much faster if documents are already fragile. Fragility of documents, fragility of paper can be described in terms of degree of polymerization of cellulose within a sheet of paper. The larger the number of monomers in a cellulose chain, the less fragile that piece of paper will be. And while summarizing material science research done in the past 30 years, we were able to describe all of the research results in a single dose response function, describing the dose of the dose of environmental, the dose of energy, if you like, or environmental parameters such as temperature, such as relative humidity, and the dose of acidity within the object, summarized in this particular term in the same dose response function. So we see now that the rate of change described by the change of dP over time depends on three particular parameters: temperature and relative humidity, and pH of paper. So we were able to summarize for the first time the two most important environmental parameters, temperature and RH, and the one most important parameter describing the quality of paper, i.e. its acidity, in the same dose response function. Why is this important? It looks complex, and it is a bit complex, but it's really important because on the basis of this function, we can now refine some of the really useful environmental management tools scientists and users have been using in the past. One of these is, of course, Sabira's isotherms. Isotherms are fairly simple functions describing permanence of materials depending on relative humidity and temperature. Rather arbitrarily, Sabira in 1994 or 1995 decided that the permanence of historic paper at 50% relative humidity and 20 degrees centigrade is 1. However, we've known for quite a long while that these curves may not represent natural aging of paper really well, because they do not take relative humidity into account. And additionally, we knew that not all paper degrades in the same way, because we knew that acidity affects degradation of paper and the rate of paper degradation. So these were long overdue in terms of revision. Now with our dose response function, we can now draw different isotherm plots. We were slightly less optimistic in terms of applicability of isotherms, so we're not trying to predict aging at relative humidity less than 20% or more than 80%. And of course, we wanted to stick to Sebira's definition of permanence of 1. We see that in our isotherms, the shape of the curves is rather different, and this is because we are now taking relative humidity into account. Additionally, we need to devise different isotherm plots for papers of different quality. Because if you remember, pH in our dose response function now matters. So we need different isotherm plots for paper of different pH, starting pH value. So this is, again, rather arbitrarily, our choice was to make the most simple plot for what is now most abundant paper, i.e. common print paper, with pH 8 and fairly high starting degree of polymerization. So we use the permanence of 1, similar to Sebira, at RH 50% and 20 degrees, at 50% RH and 20 degrees C. The isotherm curves are equally spaced as in Sebira because the dependence of rate of degradation on temperature was measured pretty accurately in Sebira's time anyway. But with these new plots, we can now explore some of the elements which contribute to paper degradation much better. And we'll talk about these elements at much more length in the frame of the workshops. We can devise isotherm plots for acidic paper, so this would be a typical acidic paper in collections. We know that European and North American collections contain about 80%, 70 to 80% of this paper. We can devise isotherm plots for alkaline paper or for contemporary paper, if you like. There's not much difference between these two, except that, obviously, the isotherm lines do not overlap, because the permanence of acidic paper is much lower than the permanence of alkaline paper. Because we now have 3 terms in our dose response function, we can also devise other isotherm plots. This is an isotherm plot for 50% relative humidity, looking at the dependence of pH on temperature. Why is such a plot useful? If I was a conservator considering deacidification, for example, and I had paper at pH 4 which I wanted to deacidify, I could then see how much deacidification to pH 7 or pH 8 would increase permanence in terms of long-term storage. And equally, at temperature at 20 degrees C, we can now look at what the effect of pH of paper or what the effect or relative effect of relative humidity is. And since these curves are at approximately 45 degrees, we see that the effect of RH and the effect of pH are very, very comparable. Finally, we were also interested in how quickly wear and tear accumulates during use of individual objects. We were interested in both bound documents and archival documents, and they were prepared using paper we knew quite a lot about. We used the Souvenir paper collection in order to bind these documents. And the reason for that is because we knew the acidity, we knew the starting degree of polymerization, so all the material properties we were interested in. And now we were interested in how quickly missing pieces and tears accumulate while these documents are used. We were also interested in whether in bound documents, wear and tear accumulates faster or slower in comparison to archival non-bound documents. This study was done with 9 volunteers at the Center for Sustainable Heritage, so big thanks to all of them who were leafing rather pointlessly through books during their weekends. And this is the result which we got. This is a rather complex plot, looking at total missing pieces per 100 sheets of paper in an unbound book, in an unbound archival folder. And we're looking at papers with degree of polymerization either 600 to 900 or large or even more than that, and looking at paper on a different scale with DP less than 300, where one challenge meant turning each page 10 times. So by the time we came to the 5th challenge, each book or each page in a book was turned 50 times already. What we see in this plot, and what is really important in this plot, is to recognize that papers with DP less than 300, with degree of polymerization less than 300, accumulated wear and tear almost 10 times faster than any other type of paper. Meaning that the DP 300 could be used as a very suitable threshold value in terms of risk of wear and tear during handling. So that could be used as a threshold value in modeling, and that's actually what we propose. We do realize that papers with slightly higher degree of polymerization still accumulate wear and tear, and we can take that into account in our calculations, but it turns out that that wear and tear accumulates at a rate which is 10 times lower than for paper with DP less than 300. We can also calculate, or based on this result, we can now also calculate the number of large missing pieces accumulating per handling during normal use in a library situation. Why is this important? If we know the frequency of access to library materials in a library or archival environment, so say if we know that the books are in general, or archival folders are in general accessed once or 10 times a year, we can calculate how many tears or missing pieces will accumulate over a period of 50 or 100 years, and take that into account in terms of modeling of thickness for permanence. Now that we have the threshold of DP 300, where we now know that the accumulation of wear and tear is very fast, we can take that number into account when drawing isoperms. Because we now have a final target in mind, we can calculate the time it takes for chemical degradation to take place to the extent that the DP drops to 300, which is where we assess the risk of manual handling to be too high. And these plots we came to call isochrones. These plots link points in terms of temperature and relative humidity during storage, where, for example, for a particular paper at 50% RH and 22 degrees C, it will take about 200 years to degrade to DP 300. So these can now be interpreted in terms of our long-term planning horizons. If our planning horizon is 500 years, which is there, for this particular paper, which is quite a typical acidic paper, pH 5 and starting DP of 600, we see that we can reach 500 years at desired lifetime at 50% RH and temperature of about 16, 17 degrees. So slightly cooler than maybe 18 or 20 degrees, which would be normal access conditions. At 20 degrees temperature, we would need to reduce the RH to approximately 40% in order to achieve the same desired lifetime, which could be achievable in terms of long storage in archives and libraries. For contemporary paper, pH 8 and fairly high starting degree of polymerization, our planning horizon of 500 years could possibly not be reached in the tropics. Because, for example, at 30 degrees C and 60% relative humidity, these might be conditions where contemporary paper might not survive 500 years. But in a typical UK or Northern European environment or US environment, for example, 20 degrees C, 50% RH, such paper will easily survive 2,000 or 3,000 years. So the question obviously arises, I'm not an environmental manager, but Kostas will talk a bit more about this, is whether or not temperature and RH really matter during storage of such paper, or to what extent. And finally, now that we have the tools to measure degree of polymerization of paper non-destructively, to measure pH of paper non-destructively, now that we know what our desired lifetime might be, 500 years, now that we know what our collection consists of, for example, acidic, contemporary, deacidified, or rack papers, we can model how quickly those collections might reach the point of being unfit for purpose at different environmental conditions. And these are our stock models, which we're going to discuss in a bit more detail later on, looking at percent of objects still being fit for purpose way into the future at different environmental conditions. This is a plot at 20 degrees C and 50% RH. We can now play and enter different environmental conditions into the calculation and see what happens with our populations. So we can manage these populations differently depending on our desired lifetime, depending on what we deem unfit for purpose, and depending on the material makeup of our collections. We're going to look into a bit more detail and how these plots can be applied later on. So we need the environmental inputs, we need the material survey inputs. Ideally, we would need to know approximate or average frequency of use in order to perform the calculations, and the outputs will be discussed during the session on environmental management of collections. I'd like to acknowledge the help of many partners and colleagues, and 331 volunteers looking at our paper samples. Thank you very much.